In this video, we are going to talk about counting problems. The first type of question we're going to look at is scheduling shifts. Suppose we have 4 employees. We call them A, B, C, D, and we need to schedule them. We need to pick 3 different people to do 3 different shifts, say like morning, afternoon, and evening. And so out of these 4 people, we can choose person A, person B, and person C. Or we can choose person A, person B, person D, or A, C, D, or B, C, D. And because after we pick these 3 people, we need to schedule them for shifts. Who is in the morning, who is in the afternoon, who is in the evening. So we can suppose we choose A, B, C to work, and we can schedule A in the morning, B in the afternoon, C in the evening. Or we can do A in the morning, C afternoon, B evening, or B morning, A afternoon, C evening, and so on. So you can see that we can change the orders of these 3 letters, and we can get 6 different ways for these 3 people, 6 different shift scheduling. And similarly, if we choose person A, B, D, we can also get 6 different ways by changing the order. And same for ACD and BCD. And if we count all of them together, we have 24 different ways, because 4 times 6, that's 24. And there's a formula we can use instead of making a list of all the possible schedulings. We can, if we are only interested in the number of different ways of scheduling, well, we can do this way. So step 1, we're gonna pick somebody for the morning shift, and we have 4 employees. That means we have 4 choices. We can choose A or B or C or D. So there are 4 possible ways to do the morning shift. And then we will choose someone for the afternoon shift. And once we pick someone for the morning shift, and we only have 4 employees left to pick from, if we gonna assuming that we have to schedule morning, afternoon, evening, 3 different people. So in the afternoon, we cannot use the person in the morning, and we only have 3 people left, so we have 3 choices. Similarly, and we only have 2 people left to choose from, to choose that for the evening shift. And so morning shift 4 choices, afternoon 3 choices, evening 2 choices, and we multiply them together, we get 24. So that's altogether 24 different ways. If we make a list, we will get 24 different ways. So this is the formula for scheduling shifts, and in this case the order matters, and we call this a permutation. And now we will look at a different scheduling. In this example, we will choose 3 people from 4 employees, but we're not gonna do the morning, afternoon, evening shifts. So these 3 people will work all day, and so in this case, we just want to pick 3 people. And from the previous example, we know that we can still do ABC, ABD, ACD, or BCD. In the previous example, because we have to do 3 different shifts, so we can change the orders of these letters, 3 letters. But in this case, since all 3 of them will work tomorrow, so either we say ABC or ACB or BAC, BCA, CAB, or CBA. These are the same 3 people working in one day. So they are kind of redundant if we want to consider how many different combinations we're gonna have. So we only have combination. We could choose person A, person B, person C, or person A, B, D, or ACD, or BCD, and there are only 4 different ways. So these two questions are different. In the first example, because the order matters. When you change the order, it's a different scheduling. But in this example, the order doesn't matter. When you change the order, it's still considered the same three people, the same way, the same schedule, the same selection. So how do we get this formula? And we can see the combination, this case is called a combination, comes from the previous example, permutation, because we can find out that permutation altogether would be 24 different ways. From step 1, morning shifts 4 choices, afternoon 3 choices, and evening 2 choices. So multiply them together, we get 24. And then we need to divide by the number of times it repeats. Each selection repeats, and we can see each selection, these 3 people, if we suppose we're going to do different shifts, we're going to have 6 different ways, because when you have 3 people, you do morning, you have 3 choices, afternoon 2 choices, and evening only 1 choice. So that's why we have 3 times 2 times 1 for scheduling 3 people. So it's different from this case. In this case, we do 4 times 3 times 2 because we have 4 people to choose, and for the morning, because we don't know who we're gonna choose, which 3 people we're gonna choose here. But in this case, suppose we already decided we're going to choose person A, person B, person C, and if you are scheduling these 3 certain people, then there are only 3 choices for the morning, because you can choose A or B or C. And then once you choose the person for the morning, you only have 2 people left for the afternoon and 1 people left for the evening. So 6. And so we can see each combination repeats 6 times in the permutation. So in order to get combination, we take all the possible permutations, which is 24, divided by 6, and then we will get 4 different possibilities. So divide by the number of times each different one repeats. So this is the formula for combination. You can see permutation, we only do multiplication here, and about combination, we got to do permutation first and divide by the number of times it repeats. So the general formula is, how do we get the top in the fraction? The top, if you have 4 people, and when you do permutation, you will start 4 and the 3 and the 2. So you need a 3 because you have 3 shifts, and 3 shifts you want to do. So of course you will have 4 times 3 times 2, 3 numbers, and 3 steps. Step 1 morning, step 2 afternoon, step 3 evening. And for the bottom, determine how many times each different way repeats. And then in this case, because we only have 3 people, we choose 3 people, so we will have 3, start from 3 instead of 4. Okay, so that's the difference. The top, because we choose from 4 employees, so in the morning you have 4 choices, but in the bottom, we already know we're going to choose ABC, for example, and so we only have 3 people you can schedule for the morning. So that's the difference, and we divide them and we get 4. So all 24 divide by 6 and you get 4 different ones. So let's look at the general formula. The rule of combinations. We have R objects from a group of N distinct objects, is denoted by N, choose R, and this is the formula. So the top is the number of permutations divided by the bottom, the number of times each different way repeats. So the formula looks complicated, but if you put in the specific example, this is what we have here. So in this case, R is, in the previous example, we choose 3 from, so it's 4, choose 3. So when we do formula 4, choose 3, we start from 4 on the top. So we have the start from the top number 4, and the big number 4, and then we go down 3 numbers. So 4, 3, 2, because we need to choose 3 people. And the bottom, we will start from the number of people we're going to choose, and then we go all the way down to 1. So that's how we calculate permutation, and that's why it's in the formula. Okay, so n choose r. Previous case 4 choose 3. So we can do anything. 10 choose 5 or 100 choose 49. So anything. And we can look at another example to compare the difference. So the permutation is only the top, just the top. And m minus r plus 1 is how far you have to go down. So for example, if we do 10 choose 4, then we start with 10 and then go down to 9 and 8 and then 7. So we 4 numbers. So which is 10 minus 4 plus 1, which is, so the last number is 7. So this, the formula tells you what the last number is, but you don't really have to memorize it because you will count how many people you want to choose. Then you will get how many numbers. You go down how many numbers, and so that's permutation. But combination, we got to divide. We use the permutation on the top, divide by the number of times it repeats. So the top will start from the big number 10, 9, 8, 7, and the bottom will start from the how many people we want to choose. We want to choose 4 people, so it's 4 all the way. You go all the way down to 1, 4, 3, 2, 1. So we have 210 combinations. Okay, so remember combination, the order doesn't matter. So when you change the order, you still get the same way. So you gotta cross them out. They don't consider this different. But in permutation, all of these consider different schedulings. Okay, now let's look at another example. If we have 16 potential jurors, which 10 are male and 6 female, the defense attorney can dismiss 4 additional persons. Part A. How many ways can the 4 additional jurors be selected for dismissal? We want to. So this question looks complicated, but its first part is looking for, has nothing to do with male or female. We have 16 persons. We want to choose 4 persons. So that's 16 choose 14. So by the formula, the top 6 start from 16. Because if you want to choose 4 people, so let's say now step 1, I'm going to choose the first person I'm going to dismiss. So first person, out of 16 person, we have 16 choices to dismiss. So you look at 16 people, which one you want to dismiss. So you have 16 possible ways. And then step 2, you only have 15 people left, and you pick one to dismiss. So 15 ways, and then 14 ways and 13 ways. So you dismiss 4 people. So 16, 15, 14, 13. And then because the order doesn't matter which one you dismiss first, so it's a combination problem. So divide by the number of ways each repeats. And so for these 4 certain people, for example, if we call them A, B, C, D, and you're going to dismiss these 4 people, then you have 4 times 3 times 2 times 1, 24 different ways to call. You may call A first to dismiss, and then B, and then C, then D. You may call A and then C, and then B, then D. Or so when you switch the order, you may have 24 different ways. But all these different ways, it doesn't matter which you call first to dismiss. It's the same 4 people. So it's combination. We have to divide by that. So by the formula, 4 times 3 times 2 times 1, and number of times each one repeats. So after division, we get 18, 20. So 16 choose 4. We have 18, 20 different ways. And part 2B, we want how many selections are possible that result in 1 male and 3 females. In this case, we want to dismiss 4 persons, but we want to dismiss 1 male and 3 females. So step 1, we dismiss 1 male because we have 10 male, so there are 10 divided by 1, that's 10 different ways. Step 2, we choose 3 females. By the formula, we have 6 male, 6 times 5 times 6 choose 3. So we have 6 times 5 times 4 divided by 3 times 2 times 1. 6 choose 3 formula, so we get 20. So step 1 times step 2, we have 200 ways to choose 1 male and 3 females. And So there are 200 ways to choose, 1 male and 3 females, and 1,820 ways to choose